Hello everyone, my name is Santanu Kumar Sahu and I am the team leader of Watt Wizards. Our problem statement title is Micro Hydro Hybrid Power Generation. Basically, our idea is power generation from existing water tank by using micro hydro and solar. Our idea is to generate power from high pressurized water flow released from the overhead water tanks. We will also be installing solar PV on and near the overhead water tanks. We'll be storing the power in a battery bank or integrating the power to the grid. The technology stack we will be using here is micro hydro turbine, solar PVs, battery bank, inverter and rectifier. So now let me explain you the our ideas. So here we have an overhead water tank, the outlet pipe of the overhead water tank. We will be installing a turbine in between the outlet pipe that will be connected to a generator. When the when a high pressurized water will be supplied from the outlet pipe, then the generator will produce some AC power. That AC power will be integrated to the grid and or we will be converting it to DC power through the rectifier and storing in the battery bank. We will also be installing some solar panels in the on the top of the overhead water tank, as we will have more space on the overhead water tank. We'll also be installing some solar PVs near the overhead water tank, as we all know, because the overhead water tanks are mostly placed in some remote areas. So we have some place near the overhead water tank where we can install some solar PVs. The DC power generated from the solar PV will get converted to AC power through the hybrid inverter and will integrate it to the grid, as well as we will store some of the power DC power in the battery bank. So now let's see the specification of the estimated overhead water tank we are going to use. So the height of the overhead water tank we are going to use is 15-meter stays. Diameter of outlet pipe is 310 mm. Velocity of water we have calculated is 18.9 meter per second. Water flow rate is 1.43 meter cube per second. Diameter of turbine we have taken is 0.15 mm and the calculated RPM of the turbine is 1200 RPM. So for all these parameters we require a 6.75 kilowatt alternator. So if we operate that alternator for 4 hours taking an efficiency of 80%, then we will get 22 kilowatt hour per day, and the average generated power from 10 kilowatt of solar is 40 kilowatt per day. So the total generated power by system is 62 kilowatt hour per day. So but initially we are approximately estimating to generate low power from the turbine so as to maintain the pressure of water, as because if we use a high power alternator and generate maximum power, then the potential energy stored in the overhead water tank will be converted to electrical energy, and there will be less kinetic energy to supply the water to the user ends. So our ultimate goal is to produce more amount of power from the turbine without hampering the pressure of water supply to the user, so as to make it net zero. Use cases where we are going to use our idea. We are going to use The government overhead water tanks, private overhead water tanks, generally 90 HP or 68 kilowatt hour pump is required to pump water to the overhead water tank. That is per day. If the pump is used for 2 hours, that is, so we get 136 kilowatt hour per day it is consuming. So we know that from solar panel 40 we are generating 40 kilowatt hour per day. From micro hydro we are generating 62 kilowatt hour per day. So sorry, 22 kilowatt per hour per day. So the total is 62 kilowatt hour per day. So to run the motor we only need 72 kilowatt hour per day from the conventional power from the grid, and our ultimate goal is to make it net zero. The challenges we are going to face are structural changes in existing overhead water tank pipes, implementation in ground level pump house, government policies, marketing our product to government to maintain the pressure of water flow. Here are the team member details and our mentor details. Thank you.